In this video, we're going to talk about how to handle the situation where you come across a 0 over 0 indeterminate form when you're trying to evaluate a limit. So in this example, we're going to take the limit as x goes to 2 of this rational function here, right? A rational function is a polynomial divided by a polynomial, which is what we've got here. So the first thing that you might try, right, is evaluating this function at 2. In other words, substituting in 2 for x and seeing what you get when you do that. So when you do that, if I plug the 2 in here, I'd have 2 squared minus 4 over 2 minus 2. 2 squared is equal to 4. So on top I have 4 minus 4, and on the bottom I have 2 minus 2. That's going to wind up to be the form 0 over 0, right? The indeterminate form. So, or an indeterminate form. There are many of those. So what do I do in this situation? Well, none of the limit laws apply, right? Because I have 0 here on the bottom. So what I'm going to do is to just take a look at this function right here. This is a rational function, right? And so when I plugged in this 2 and I got a 0 in here, what that really means, if you remember back to college algebra, is that I can factor out an x minus 2 out of that polynomial by the factor theorem. And I can do the same thing down here. So for a rational function, when you have the 0 over 0 case, what you want to do is factor everything as much as you can. So when you do that, right, this top part is the difference of two squares. So it will factor down to x minus 2, x plus 2. Okay, and of course the bottom is as factors as it can get. So once you factor everything out, right, you can see, hey, there's a common factor here of x minus 2 over x minus 2. And so what you can do is cancel those factors out. Okay. Now you may say, well, wait a second. If I plug the 2 in there, right, I get 0 over 0, right? And you already told me that's an indeterminate form. So how can you really cancel those two things out? And well, the thing is, right, about the limit is that remember, the limit describes what's happening to the y values the closer and closer the x values get to 2, but not equal to 2, right? So we don't really care, the limit, and the limit doesn't care what happens exactly at 2. And for any other number besides 2, like 2.1, 2.01, or whatever, any other number besides 2, this will be exactly equal to 1. So we're going to cancel these two things out. We would wind up with this limit right here, which is a really simple limit, right? After we cancel that x minus 2 out. And we would evaluate that by substituting a 2 in here. We get 2 plus 2, right, is equal to 4. So the correct answer for this limit problem is equal to 4 here. So this example shows, right, that 0 over 0, you couldn't really define it the way most people want to, right, because this limit problem comes out to be 4. And the way this is, if you give me any number, say like 15, right, I can come up with a problem where when you evaluate it, it's 0 over 0, and the real answer is 15. So 0 over 0 right here is truly a meaningless thing, and it has no bearing on what the final answer is going to be. The final answer could be anything based on this. So 0 over 0 is just a form that you encounter when you're working on some of these limit problems, and what it means is that you need to do something else to find out what the limit is. In the case that you're dealing with a rational function like this, what you're going to do is you're going to factor the top and the bottom, and because it was 0 over 0, you're guaranteed, right, in the case of a rational function, that you're going to be able to cancel out a common factor in there. And so that's the technique that you would use for a rational function like this, in the case you got 0 over 0.